Well, I'm Badr Benjeloun. I'm glad to meet you again in this new conference of the INRA Webinar series dedicated to discuss trends and innovations in agriculture. I would like to welcome all the participants from different countries, maybe for taking the time and to attend this webinar, and probably also to enrich the discussion by their questions and comments. Before we start, I want to ask all the participants via Zoom to add and to mention their full names and affiliation as your login, please. If you don't know how to do, you can click on participants in the bottom of the window, then click on your name and select rename. So we will give all participants about 5 minutes to do this. Then colleagues will remove all participants who are not identified at all. Thanks for your understanding. Then I would like to thank warmly our guest speaker for accepting our invitation to share his deep experience and knowledge with us. I will give directly the floor to my colleague, Dr. Muha Farrahi, to introduce our guest speaker and the webinar topic. Dr. Farrahi will also moderate the Q&A session after the talk. So, Dr. Farrahi, the floor is yours.
Thank you, Dr. Benjeloun. Welcome, Dr. Dr. Filippo, and thank you, colleagues, for attending our webinar. It's a great pleasure for us to have you today with us, to share the trend in science and what has been done in this, particularly in this climate change aspects. So all of you know climate change is really a fact. And this year has given us a real touch about what does mean climate change. And there is really a decrease in rainfall. And this year we have almost 2 months in Morocco without any drop of rain. So we are really experiencing what climate change does mean. In this context, we agreed at the organization committee of the INRA webinar series that our talk of this month will be really a subject that deals with climate change. And we are glad to have Dr. Filippo Bassi from ICARDA, Morocco. And I talked to him here, immediately accepted the idea to give us a talk on this subject. And he will be talking about adapting durum to climate change in North Africa and in Sahel. I will give very brief, just in a few words, an introduction about Dr. Filippo Bassi. He is from Italy and he is working for ICARDA since 2012. He holds a PhD in plant breeding and genetics in 2013 from North Dakota State University from the United States. He has a master's degree in biotechnology. It's a joint master's degree from Italy and Adelaide in Australia. He has a base in plant biotechnology and agriculture in 2005 in Italy. For his position, he was a research fellow at the Australian Centre for Plant Function Genomics, 2006-2008. He was also a research fellow at the Department of Agro-Environmental Science and Technology in Italy from 2009 to 2008 and 9. He was a research fellow, PhD at North Dakota State University, 2009-2012. Then he joined ICARDA as an associate durum wheat breeder, 2012-2014. Then durum wheat breeder at ICARDA, 2014-17. And now he's senior durum wheat breeder, senior scientist at ICARDA, Morocco, since February 2018. He's a very productive scientist. He has more than 41 peer-reviewed articles in really high-level scientific publications, where he has an awarded outstanding article in 2020, and also he holds second most download article in plant science. He has so many awards. We have mentioned one in our flyer, that was 2017 Olin Prize for Innovation in Food Security. But he has also 3 other awards. He has 4 scholarships during his career. His some of scientific activities. He's a member of the Scientific Steering Committee of the Expert Working Group with the WIT Initiative. He's a member of the Crop Science Society, 2013-17. He's a member of the Italian Federation of Biotechnologists, 2010 to date. He's a member of the National Association of Plant Breeding, 2013 to date. He's Associate Editor of Frontier in Plant Science, 2017 to date. He has released so many varieties, 34 varieties, since he was working on Genomics for the region of MENA and Africa. And we are glad to have one variety released by Filippo in Morocco, that's Nasheed, and still varieties are coming. He has 13 funded grants since 2013, and we both, me and Filippo, are PI of the MCGP Morocco ICARDA project in enhancing genetic gaining of cereals and legumes. And I will finish for his research activities, so many activities in pre-breeding mainly, and breeding, accelerate genetic gain, conduct new product profiles, redefining breeding cycle, breeding for climate change, innovation, promotion of novel food, value chains, and integration of research, gender in research. And also he has activities in agronomy, mainly G by E by N, that is most important also in the research. He is involved in the seed system. He's working with us in seed increase in Morocco, and he's helping us on that. And I will say that Filippo is a strong believer in the use of wild relatives to achieve better stress tolerance. And I will finish with some of his hobbies. He's a former professional of water polo player, and he has also other hobbies. I will stop that. I will stop in this. I give you the floor, Dr. Badr.
Thank
you very much. Sorry. Is that okay?
Sorry. Thanks, Dr. Falahi, for this nice and rich introduction. Before giving the floor to you, Dr. Bassi, to start your talk, I would like to mention that this talk will take up to 30 minutes, and then we will have the discussion session that will take up to 20 minutes. For the discussion, please post your written questions via the chat on Zoom. Please fill in your name and affiliation before the question, and do not wait until the end of the conference to ask them. You can post your question in English or French as well. Also, people who would like to ask their question directly can raise their electronic hands, and we will give you the floor also. So we look forward to listening to you, Dr. Bassi, and to knowing more about this interesting topic. The floor is yours, Dr. Bassi.
Thank you very much. I was joined by Ahmed Amri.
I'm here in his office.
So he's here, he's listening directly. So he says anything stupid, he can slap me from the back. And probably thank you very much for the CV that you so elegantly listed. I have to admit that water polo I'm no longer doing since 2-3 years. It's a shame. I was playing with the Rabat team. We won the championship in Morocco, but it's been a while since I played last time. And also I have to always recognize that I came after a great breeder, who is Miloudi Nasheed, was my predecessor, and he left me with great germplasm. So one of the reasons why I was able to release so much so quickly is, in fact, releasing from material that he had developed. So with that, with no further ado, climate change is here. We have rain today, which is great. And we hope to keep on having rains. We need to fill those barrages empty, but yeah, the cereal season has been severely affected. And in my presentation today, I will mention how we try to target that. Since I'm not hearing anything, I assume you can see my screen correctly. This is a nice picture of Marchouche last year, and we really had a very good year. This year would not look quite like the same, but I still invite everybody to come and see what we do up there. So this is the most updated I could be in terms of the crop status for Morocco. This is from FAO JUICE. This is the map as of end of February. The red colors means area that highly affected by drought. So you clearly see most of Morocco has been heavily affected by droughts, with the exception of some of the coastal zone that were able to maintain some of their production, and the areas of Fes Meknes that has been a little bit less affected. Just out of comparison, this is what February 2020 looked like, same time. And again, 2020 was a bad year, right? There was a lot of reduction in terms of productivity. So this really shows how bad this year really is going to be. And this just shows the area where durum wheat is cultivated. So you can clearly see, if you look at the two map, the most of the durum production area is affected by drought. In fact, we even had a little bit of delayed bad year again, was 31% below total.
Dr. Bassi, we lost you for a few seconds.
I hope I'm back. Sometimes my internet goes
now
down.
it's okay.
Yeah, I'm sorry, I
Okay.
apologize.
Perfect.
So I was saying that we are 64% less rainfall than we were in 2020. The estimates, rough estimates of productivity would be between 7 to 8 million quintals of durum wheat this year, which if the average total needs remain the same, the industry will need to import about 11 million quintals. So that's quite a bit of durum that will need to be imported. And this is actually a picture of what it looks like in the world at the moment. Of course, all the southern hemisphere is not cultivating wheat at the moment, but all the northern hemisphere is cultivating wheat. And you can see that Morocco is not alone. Algeria is suffering, Tunisia is suffering, the border between Turkey and Syria and Iran is suffering, south of Spain is suffering, and the violet means that the satellite cannot still detect the crop compared to the ground, which is also a bad story, because by now March in a lot of Europe, normally the crop should be sufficiently developed to be detected. It is not yet the case, and my experience driving through Italy is that also Europe is suffering from drought, not just Spain, but also Italy. And this is probably the most scary numbers that most of us are aware of. This is the level of durum imports in 2019. Okay, so it changes every year, but this is about correct. This is the biggest importer in the world of durum wheat is actually Egypt, followed by Italy and China. But there's also Nigeria there, Algeria, Morocco imports about 3%, 2.5% of the total durum imports. This is a $8.11 billion business, not a small business. And the biggest exporters are this one. Of course, Russia and Ukraine this year will not be exporting durum wheat. And so that creates big stress in the market. And the market is terribly stressed already. This is because in 2020-21, so summer 21, Canada had a terrible, terrible drought. So even before the war, even before the drought that is affecting all the area, the durum wheat price at $720 per metric ton. This is not a high price. This is double the highest price durum wheat has ever been. So the cost of each couscous will double 3 times just to meet this cost increase. And this is before we consider the effect of Ukraine and Russia not exporting, before we consider the effect of drought. So we can expect that minimum $700 per dirhams will be required. 300 dirhams per quintal will be required for the imports. And with the 11 million quintals that Morocco needs to import, that's a 7.7 billion dirhams bill minimum that Morocco will have to pay this year. So of course, the scary part is, okay, this year we can tighten the belt and survive this. But what happens if this repeats next year? What if the war in Ukraine lasts 5 years? What if Canada has another drought? What if we keep having droughts here? This is a very scary situation. And of course, you know, as a scientist, as a player trying to see what a change could look like, I just ask myself, what would happen if we invested 1 billion dirham of this, try to improve production instead of favoring imports? Could that be enough? I don't know. And of course, Morocco, in Morocco, drought is not an exception, right? This is from the climate change plan. This is Morocco. This is the rainfall of the total season between October and June in the year 2050. Okay, so 30 years from now, most of the country is yellow, which means that the average rainfall will be between 150 and 300 millimeters, which is a dry production, is below what we have today. And of course, if you compare that with the change in terms of rainfall, not all the country is red, but there's quite a bit of area that will lose between 10 and 30% of rainfall compared to today. So that's a big issue. That's something we have to keep in mind. And for that, I think it's very important that Morocco really thinks about a drought adaptation plan for its cereals. I think as a breeder, I think varieties have a big role to play, agronomy as well. And of course, there's also a question, right? The durum and barley exporters are very few around the world, while the bread wheat exporters are many. So could we, as a country, consider, you know, producing all the needs for durum and barley, and maybe, you know, keep relying on imports for bread wheat? That's one option. So, and under the Generation Green Plan, INRA has committed with this partner to try to double the yields of cereals. And if you take, this is a 5-year average, the durum wheat average yield is 18 quintals. But in 2020, which was a dry year, the yield dropped by 9.6, right, by half. So, of course, if I'm thinking about doubling the yields, I need to double both the 18 and the 9.6. And of course, under irrigated condition, that yield did not change, right? Under irrigated condition, the yield is good. It can even actually go a little bit higher. It's under rain-fed condition that the yields fluctuated with the droughts. And because a lot of durum is produced in rain-fed condition, it's so critical, the partnership between INRA and ICARDA, to really try to increase yield under these harsh conditions. Right? So one way that we actually make this partnership work, and we're starting recently, is called product profile. Product profile is a contract. This, for instance, was submitted in 2019 by Dr. Amamo, breeder at INRA, right? A durum breeder. And I'm involved in this. Dahan was involved, and many others. You see Muna, you see Ferahi, several people. And this contract says that we want to develop together a variety that has the gluten strength of Marzak, accession fire resistance, and so on. And basically, there are two product profiles that we have agreed upon with INRA. This is INRA-ICARDA partnership, which of course is not the only partnership. So one is for the dry land. We want to develop a variety with good drought tolerance that yields 10% more than Bonidur, which is the main variety today, under dry condition, has larger grains, has very good processing quality for the industry, and is resistant to Asian fly. This is key, and is also tolerant to heat. A second one that we want to try to work on is for the mountain, very abandoned area where the productivity has remained stable in the past century. So to help the mountain, we want to develop a variety that have cold, have large grains, and especially are very good for household use, converting to breads and all that. So under this goal, Dr. Taguti of INRA released the variety Nashit. Nashit is a variety developed by our gene bank, originally, as tritodicocoides in it, then was selected by Miludi, then by me, and then ultimately by our INRA partners. It's a very drought-tolerant variety with very large grains, so we're very happy with it. In fact, this is an example of how this variety performs. So here you have the different season, 5 total season, and the average overall. This line here represents Karim, so 100%, right? It's Karim, the main cultivated variety up until now. And then you have in orange, you have Faraj. In yellow, you have Nashit, which is the one that we are talking about. And in gray, you have this Bonidur. And I just want to drag your attention to two particularly bad years. 2016-17, the average yield of Karim went down to 2.7 tons, which is his own station, so it's quite low. And this is Marchou station. And Nasheed produced 36% more. But very bad, 2019-20 years, Karim also almost produced nothing, and Nasheed produced 24% more. So, and on average, it's a 15% increase in productivity. So this is quite a good variety, right? That meets a lot of the demands for that product profile. Has higher yields for drought, has larger grains. Nasheed has very large grains. Is resistant to root rot, leaf rust, and to stem rust, which are very important disease package, but it is not resistant to Asian fly. So it is still not that perfect variety. But of course, as a breeder, as a scientist, one must be, okay, if it is drought tolerant, where is this drought tolerance coming from? So while studying it, we realized that there's a big element in the roots, probably coming from its dicocoides origin. This variety has deeper roots, so if it's able to find moisture in the lower part of the soil. And when we studied at the molecular level, we identified 3 genes. And when you have all 3 combined, you yield much more than when you don't have them. In fact, it's about 300 kilograms. But that's not enough. Okay, so this work is what received the outstanding paper award, because of course it's not very common that you're able to explain drought so clearly, drought tolerance so clearly. We actually want to test Nasheed on farm, and we partnered with NORAD and the Crop Trust, and we tested it in 19 farms across Morocco. This is averages for regions. We have the region of Delt, Eit Bohou, and Guigou, which are mountain, right? This is Atlas region. Then you have Marchou here. Then you have 2 irrigated zone, one close to Tessaout, the other close to Tedla. And again, as before, this line represents Karim 100%. This represents a variation in terms of yield, Karim. So you have Nasheed is the orange one. And basically, you can see that under dry condition, Nasheed did between 18 and 70% better. So in particular, the average, this root type that goes down ensure a 38% yield advantage over Karim on farm. So directly by farmers, not by us. And that also came with larger grains. The thing we did not expect is that actually it also performed better under irrigation, which is actually quite interesting. We now realize how well Nasheed performs under irrigation. So that's quite. But of course, as I said, I'm a scientist and I want to know more. So this large grain size for me is a very, very interesting trait. So what we did, we developed new populations crossing Nasheed to 1, 2, and 3 other elites. And this is the distribution for grain size. Basically, you see that we were able to develop new lines that have larger grain size. And now we are in the process of trying to find the genomic regions that actually controls this grain size. And actually, we do have it somewhat. And now we will be able to use that to move forward in the breeding process. Asian fly. Asian fly is definitely a Moroccan problem. It's a big Moroccan problem. For those of you that are not familiar, when you have Asian fly, in fact, this is a resistant variety of Asian fly. This is a susceptible variety of Asian fly. So if this pest comes, and it's a very nasty pest with wings, then, and you have a susceptible variety, this is what you harvest. Nothing. You can see it. If you have a resistant variety, you harvest like normal, like nothing has happened. So this is a very long story. And in fact, a lot of farmers confuse the effect of droughts with the actual effect of Asian fly. So that's a very scary type of insect. This story is a long one. It started in 1989 with the person next to me and a group of his colleagues and friends that went to Kansas State University and identified some material that was resistant to this pest. By 2003, the work of people like Nasrallah ensured the release of 3 varieties that were resistant to Asian fly, making Morocco the first country to release Asian fly resistant varieties. And the work of ICARDA in partnership with INRA, and this is a very good example of the importance of this partnership, resulted in a release of another variety called Faraj. And my little contribution in this story was to actually identify the genomic, the DNA that actually controls this resistance. Now we have a very nice marker that predicts with 100% precision the resistant variety. So using this molecular marker, I can stream a lot of lines and know which one are resistant. The market is not the gene, is not perfect. We still have a little bit of false negative, but all in all, as a breeder, the fact that when the market tells me this is resistant, it is really resistant. This is for me is more important. So as I said, Asian fly is in fact is a Moroccan problem, but it does have a solution. You have an example here of this famous 2016 bad year, where the rain favor, the delaying rain and drought favor Asian fly. You see Farage and Karim planted side by side in Marshush under the same plot and all the conditions. You see how much more Farage produced thanks to its resistance to Asian fly. So this really shows that it's a Moroccan problem, but we do have a solution. It's called Farage. We have that solution. Unfortunately, when you look at, these are the data from Sonacos for 2021 sales. And I just grouped them by variety that are more than 10 years old, more than 20 years old, more than 30 years old. By the way, in Morocco, there's no variety that is less than 10 years old. That's actually an issue. But anyway, when you look at them, you see Kanakis, Prosper, and Bonidur are the major variety today. And together with Carioca, they're all European origin. None of them is resistant. In fact, if you go look which one are the resistant one, you have Farage, you have Marwan, Shawi, and Nasira. It represents less than 1% of the total area. So even if Morocco was one of the first countries in the world to release Asian fly resistant varieties, today less than 1% of the area is cultivated. This is an issue. This is an issue of national security. There are areas of Morocco where the cultivation of Asian fly resistant varieties should be mandatory. We have states like South Dakota in the United States, where varieties that are not Asian fly resistant cannot be cultivated. Because if you have them and Asian fly arrives, you lose a lot of production. And then the country needs to import, needs to pay insurances and so forth. So it's a matter of national security to impose the use of Asian fly resistant varieties. And of course, Farage is not a perfect variety. So together with our colleagues at INRA and Dr. Farai, two more were submitted in the last year and this year. One is called Gigamore, the other one is called Zina. You see them here performing. They combine the 3 QTL for droughts of Nasheed with this one for Asian fly resistance. Again, you have here, this is the example of Karim. The blue one is Gigamore and the green one is Zina. You see that in CDL ID, over the past 5 years, on average, they produce up to 60% more than Karim. That's a lot. And in particular, this year here, 2018-19, where Asian fly really came, you have Karim producing less than a ton, and these two varieties producing 3 tons. This is a huge difference. So that's why I'm saying area like Sitat, in area like Safi, Asian fly resistance is a must, is a matter of national security. One more element that I want to discuss is heat tolerance. This we don't see it enough because rain is more visible and heat is a little bit hidden. But heat, as a matter of fact, is even a bigger killer than drought. And so, in order to test what we developed, we start placing these plastic tunnels on top of the durum plots when the plant was flowering. So we were imposing a heat stress of up to 10 degrees above when the plant was flowering. And the temperature inside here went to almost 40 degrees, 38. And what you see is that compared to normal condition, the grain yield was reduced by half under the heat condition. And the factor that was really influencing this was the grain number per spike. So the fact that we have pollen that dries out and female gametes that dries out due to high temperature makes it impossible for the grains to produce, and then you have this effect. But this was not enough. There's a place very close to us, is the Senegal River, where temperatures are always very, very high. So we went there, and what's happening there, that we have one cultivation of rice, another cultivation of rice, and then you had a period of 3 months and a half that was left as fallow. But the temperature are always above 32 degrees. And so we tried to develop heat-tolerant variety for that region. We actually succeeded with the release of 3 of them, Habi, Amina, and Yufisa. These are heat-tolerant varieties, really adapted to this very high temperature condition in the Senegal Valley. You see them here, there's actually quite good looking wheat. But in that case, we didn't have a seed system for wheat place. So what we did instead, we trained these female cooperatives to become the driver, to become seed enterprises They were very successful in very quickly, in less than 4 years, moved from 0 hectares to more than 4,000 hectares of wheat cultivation today, and it's still climbing. So this is a good example of how to really target this type of issues. But of course, again, I'm a breeder, I'm a genetician, so we tested the germplasm under the Senegal River. You see these are different plots, tested Elis in Mauritania. We combined a study with the plastic tunnels, with the things here in the Senegal River, and we identified 2 very important genes right here. When you have them, you increase by half a ton your yields on heat strike. So this is very, very good example of a very practical solution using molecular tools. And when you ask it, okay, where are these genes? Actually, these 2 killias are inside a variety called Margherita. This variety Margherita has been released in 2020 in Lebanon and has been highly appreciated in Morocco. Last season, there was a wet season. In fact, Margherita is a good variety when you have moisture. It's not very drought tolerant, but it's very highly productive and heat tolerant. So it could be good for area like Fez and Meknes. But from Morocco, we've been shipping variety like Margherita, Nashit, and others all over Africa, because when we were awarded this Holland Prize for Innovation Food Security, a lot of farmers became aware of it and they contacted us and they keep on asking. And I have a list of backlog of people that are requesting this variety to test them in different countries. So really Morocco is serving all sub-Saharan Africa with this heat tolerant wheat. One a little bit crazy idea that we had when we were trying to produce seeds, and then we realized it was more useful than that. So if you have a heat tolerant variety, you can go to the south of Morocco. This in particular is Merkezer, this is south of Agadir, but we did this similar experiment also in Laayoune. And what we do, we took the dripper that were used for the tomato, right? After the tomato is thrown away, we took it. We provided 350 to 400 millimeters of water with the dripper together with irrigation. This is called fertigation. And what we were able to achieve on this is sand, this is desert, this is pretty sand. Very high yields with very high protein. And this is great because these type of high quality grains are really what the industry is importing from Canada. Now we might have a way of producing them right here in Morocco very effectively. So this is a little bit interesting for me. And in fact, we went on and we discussed with some of the cooperatives in Laayoune, and they're very excited to produce true oasis food, right? Producing the durums and the barley directly in these desert conditions, and then take them and maybe link them to the desalinized water, to the solar systems, and altogether they get new economy that they can use. Maybe the camels get more straw for their needs, and at the same time we are improving this very sandy soil, trying to protect it from further desertification. That's something I'm really hoping to see scale one day. One more element that I want to add to our conversation is zero tillage, conservation agriculture. I think Morocco very courageously and very correctly committed to reach 1 million hectares conservation agriculture in the next decade. But as a breeder, of course, I ask myself, is that good or a bad thing? So what we did is a data from 2 years. We planted side by side. This is Marchouche using zero till planter, or a normal till plant, conventional till. What I realized that the best performing line on the zero till was not very good performing in conventional tillage. The same here, the best for the conventional tillage was not the best performing in the zero till. To me as a breeder, that was information enough. If I want to make my germplasm being great for conservation agriculture, I need to breed under conservation agriculture. So all my fields in Marchouche, whenever you want to come and see them, they are all planted under zero till on full retention of fava bean stubble. And you will see that this will pay in the long run. Those varieties coming out will be very adapted to conservation agriculture. So I covered some of the elements, and together, this is a study done in the 90s, and we just improve on it a little bit using more recent data. This is basically when it's just looking at the wheat production, right? And its yield components. So basically it says that when an early season stress occurs, like this year, what you have less germination, so you produce less plants per meter square. And also the number of spikes per meter square, how many spikes you have produced, goes down. If the stress continues, like that happened to us, also the spikelet that gets produced, they become very small, so you get very small spikes. And the biomass of your crop goes down, which means you don't have enough biomass, you don't have harvest index. Then if the heat comes later on in the flowering, you lose the number of grains per spike. I mentioned that, the pollen dries out. And as you have droughts at the terminal stage, that is all determining the grain weight, and the roots really play a major role in the system. So if you think about climate change and what it will look like, we will have more droughts. So for that, we need to develop variety with deeper roots, higher grain weight, and also higher spikes per meter square. As the heat waves increase in frequency, we need higher spike frequency. As the season becomes shorter, we need early flowering time. And also there's a number of damaging pests and diseases, including HF. And of course, as a person, it would be very difficult for me to work on all these elements, right? So what we did, we reached out to the whole community, the whole durum wheat community. We developed this panel with a number of partners. It is called the Global Durum Panel. It represents more than 1,000 entries that correspond to basically the major part of diversity that you have for durum wheat worldwide. And then we provided it to different partners around the world. Each one of them, this for instance is India, or this one is Lebanon. Each one of them is now using this panel to test for a specific phenotype. And the goal here is that if somebody in Ethiopia finds a good line for rust resistance, he can tell that to somebody in Canada. They will then take this variety out and combine it. This is a way to discover new alleles, exchange them, but also to give opportunity for students to work within the community across places. So this is something that we have in Morocco is working quite well. To come toward the end here, Dr. Ferrari correctly mentioned we are both co-leading MCGP, which is a collaborative project between Morocco and us, ICARDA, and the genetic gain. And one element that we want to look at is the overall pipeline, how things, the synergies between ICARDA and INRA. So as ICARDA, we start with the crossing program. We use shuttle breeding, and for that we have developed the station of an aster in the Atlas Mountain to work as off-season. Then we do 2 years of yield testing here in Morocco. Then we do a multiplication, actually in Lebanon. We generate international nursery that we provide to INRA. INRA then selects the best, conducts 3 years of yield testing, purifies them, multiplies them, presents this to the release catalog, to ONSA, for 2 years. Then once something is released, they try to sell it as a variety. And once the variety is sold, then the production of seeds, the 0G1 starts until it goes to the multiplicator that multiply and commercialize them. So this is a 21 years pipeline. So the cross I make today will see the farmer's field 21 years from now if nothing happens. And in fact, we had called, INRA is called for a stakeholder consultation with the major players of the seed system. And it was a unanimous inputs that INRA varieties are very good, but the seed amount is not there. INRA needs to work harder in producing enough seeds. And I know that Dr. Ferrari and his colleagues are doing great work at that. So again, on the MCGP, we took up this information. We came up with a different scheme. So first of all, at the ICARDA end, we tried to accelerate our work using the speed breeding and genomic selection facility that we have built and we soon will inaugurate in Rabat. And then INRA, instead of waiting for this international nursery system and so forth, we have agreed to generate a project trial for 3 years where we really test the best of the best. And as we are testing, we're already purifying so that we can much faster go to release. And then we decide not to wait for the variety to be released and immediately work on producing the G0 seeds. And then in the meantime, you can sell the variety, right? It can be sold as G1, doesn't need to be sold as 0. So this is the idea of accelerating. In doing this, we are able to shave 6 years away from the. In conclusion, I'm sorry, but Moroccan farmers are destined to suffer droughts. It's in the future, and years like this one will become more and more frequent. So it's very important that together we think of a drought cereal plan to really tackle this approach, whether by using new favorable areas like the fertigation, or trying to find better ways of using the unfavorable ones, like imposing action fly resistant, conservation agriculture, and also select the right crop species to produce. And of course, as a breeder, all this comes to a product profile. Also, as an agroecologist, we have to stop trying to develop a variety that covers the whole country and focus. The partnership is providing very good germplasm. You see here a nice picture with Amri making lots and lots of crosses. And in fact, our gene bank has been fundamental to develop this type of material. But I don't know if INRA gene bank has the same capacity. So probably there's a space there to improve this linkage, maybe under the same project. And again, we have developed a new way to accelerate our way of delivering seeds, but maybe that will also require a revision of some of the catalog procedures to really align all together to this drought adaptation in natural setting. In conclusion, to me as a breeder, variety is a stepping block for climate change adaptation. We have drought-tolerant variety and non-drought tolerant. So it is very important that we consider this as a climate solution, and we address this as the importance that it has. In a country where drought is constant, having drought-tolerant variety is a must. And that must should be legal and political, not just decided based on benefits and seed market. With that, I thank you for the attention. I show a picture of Marshush in a very dry year and the Zerotill. This year will be not quite as good, but I still invite all of you to come and see it. Thank you.
Thanks, Dr. Bassi, for this rich talk. I will give the floor to my colleague, Dr. Farahi, to moderate this session of the question answers.
Thank you, Badr. Thank you so much, Dr. Filippo, for your talk. It was rich, and it took us and discover how important is working on variety, developing varieties that is really more resilient, drought and heat tolerance. And if we have acreage of these important varieties this year, I'm sure that we will produce a little bit more than is expected to produce right now. Colleagues, if you have questions, you can just post them in the chat. If you wish, you can raise your hand and I will give you the floor to ask your question directly to Dr. Filippo. We'll go to the discussion. I will see if we have, we don't have any questions in the chat.
I see Professor Bekawi with his hand raised.
Okay.
Notice that.
I didn't see. I could not see. Okay, yeah. You have the floor, Dr. Bekawi.
Okay, thank you. Thank you. Thank you, Filippo, for an excellent presentation with very pertinent data, particular of this year of drought. And we're looking forward to the transfer of these lines to the Moroccan farmer within the next years coming up. I'm assuming Nasheed and Faraj are in the early stage of multiplication, but we will work with Sonacos to ensure that if they are your best lines and INRA and ICARDA best lines, then we need to focus. The multiplication process is a long one, and we need to pick the best line to ensure that there is focus on this line. And I realize that there is a continuous improvement with the future lines, but the message needs to pass to the seed multiplicator, to Sonacos and the farmers. And your presentation, I think, highlights some interesting data. I have one comment and one question. The comment is about the target yield. You mentioned that within the new strategy would like to double the yield. We would like to. That is said, the objective we gave ourselves is 50% within 2030. If the scientist wants to keep it doubling, I'm okay with you. But so basically, we have on average, let's say, very simplified, 20 quintal or 2 tons per hectare as the average. We would like to go to 3 tons per hectare by 2030. And I think it's feasible with the progress that's been made and all the agronomical practices that are not done in most of the farms in Morocco. I think it's a very achievable target. And I think with the improvement that the breeders are coming up, I think we could do maybe better, but we need to I'm sure we do better in the research stations, but we need to do better at the farmer's field. So the second is a question. With this year of drought, are you going to be able to select some lines that are going to be outstanding, that are going to come up out of the crowd, that maybe could be even more interesting for your program? Thank you. And thanks again for a very excellent presentation.
Thank you, Dr. Kawi, for your comments and question. I give you the floor, Dr. Filippo Bassi, to answer the question and comments of Dr. Kawi.
Thank you very much. So yeah, right. Sorry, 50%. Doubling, I got excited there a second. But to me, it's important the message passes that under irrigation, so favorable condition, we can definitely make a gain. There's a gain to be made in a favorable condition, no questions about that. But I think where we can really make a revolution is in drylands, is in rain-fed agriculture. Just incorporating these Asian fly resistant genes, just a very simple thing, Asian fly resistant genes. It means that 1 year every 3, you will double your yields, if not more. So then you take the average across the 3 years, you make sure the variety is a little bit better than the one before. I think we can achieve a lot. And in fact, if you look at the breakout by region, right, sometimes we are able to find this data from the ministry. It's not always available to us researcher. But when you see that by region, the region that they maintain the productivity every year, right? The yields is very similar. Then there are regions that based on the rain, they go up and down. I think it's here that we really change the average. So that's, I think, where we're gonna do the biggest impact. And also we could also add more area where yields is stable. That's another thing we can consider, right? What happens if you put barley under irrigation? That would stabilize a lot the yields of barley and maybe push it up. The same for durum. Now, I do think that farage, which is now theoretically, as far as I know, is a sold variety, is in the hands of Sonacos, should be scaled into farmers' fields. I am not sure why that has not happened yet. But that is a national fly resistant variety that if we had it in farmers' field this year in the Safi and Setat region, less farms will have been raised. Okay, less farm will have been raised. I'm not even talking about gain of productivity, but not all the farm will have been raised. So that's a big issue in terms of national security. Nasheed is now under production. We had certified G1. Dr. Taguti had done that in 2020, but then the production need to restart it. So I think now we are producing it, and maybe there's a need to look at production. Coming to the last question, which is probably the most interesting, and that's a dream of every breeder, right? Yes, this year we will be able to select varieties that are going to be absolutely outstanding for drought tolerance. This is clear. I mean, when you have years like this, as a breeder, you have to capitalize on them and get the maximum out of it. To the point that we have risked losing the whole season just to be able to find a few lines that are actually outstanding. Of course, then you have to adapt them for the rest. You know, when you push too much in drought tolerance, then maybe you lose a little bit of yield potential. So there's going to be a little bit of game to be played. But invite all the colleagues to go together to Marshush and let's go find these incredible things are the future for this country. So let's go find them together.
Thank you, Filippo. I have questions in the chat. The first question is from our colleague Arfeni Abdelaziz from Syngenta. And his question is as follows. For durum wheat, it's okay for breeding with different resistance, as an example, Nasheed. But what about seed care or treatment? Is there any plan to develop this aspect in Morocco, like in Italy, with pasta makers, USA and Canada, with appropriate seed care coupled with good varieties, yield increase can be minimum by 15%. And there is an ongoing project between Syngenta and INRA Morocco, and we are working actually in 2 regions, Drought and Mershoush. So it's a question about the seed care coupled with varieties.
Yeah, so at ICARDA, we actually treat our seeds. We have treated them for a long time with Vitavax, which was the least effective treatment. Now we are obliged to treat everything with Celestop. So in fact, some of the things that you are seeing means also the seeds were actually treated with Celestop. On the other hand, we treat all the material with the same treatment. So, you know, try to stabilize it. So as a breeder, I do believe that there's a number of diseases that I don't have to focus on because we have seed coating and even fungicide, by the way, that can really come into play. I mean, there are a lot of fungicide that with as little as 150 dirhams per hectare, you protect by a disease. So as a breeder, I'm very happy and aware of those. Now, let's not forget that most of the things I work on is for the end of the season, right? And so like Septoria can be controlled quite well by seed treatments. On the other hand, when you go to the end of the season, things like Fusarium head blight, which I don't work on, but especially for me is Fusarium culmorum, the root rot, foot rot, that cannot be controlled well by seed. So I think there's a space for both. I really enjoy the fact that there's seed treatments that help me reduce the number of traits I need to work on. I'm happy there's fungicide that do the same, but there are still some that I think are important. So for me, this would be stem rust and root rot, and definitely Asian fly.
I have another question from the chat from Melvin on Diva. Thank you so much for your presentation. Good presentation. My question is on Haitian fly. You mentioned earlier that this fly is a major problem in Morocco. However, there is a solution to it. Did you mean that Faraj and Karim are the other plant varieties that are grown to solve the problem? Please, someone is talking, please mute your microphone, please. So he's asking about, he wants you to elaborate more on this Haitian fly problem, because we have a solution for that and why it's still a big problem.
Problem. Okay, not good, because the whole I was blocked from unmuting. So right. So Karim is not resistant to Asian fly, so we should not discuss it. I do hear there are some seed coating that might be good against Asian fly. Should make a correction. I'm not aware of those, but I hear sometimes it works. So happy. Of course, pesticide use is, yeah, I don't know. It's not very green as an approach, but could be an option. Faraj is resistant to Asian fly, and so is Shuya, Nasira, and Marwa. Marwan, right? So these are all release varieties. They have other issues. They're not perfect, but something like Faraj is pretty bloody good. It's a very good variety, and I think right now it should have been in farmers' field. So when I say that Asian fly is a Moroccan problem with a solution, yes, the solution to Asian fly is these resistant varieties that are already sold to Sonacos, that are already in the process of being multiplied. I mean, I don't want to share my screen again, but if you look back to my presentation, you will see that they are among the certified seeds sold, but they represent 1% of the total, so it's very tiny. So that's why I'm saying, as Morocco, I think it would be correct that ONSA imposes a law that for variety in the area of Setat, Safi, only Asian fly resistant variety can be sold in this area. Only. Because for Morocco, not having them is a major issue. And honestly, farmers do not see Asian fly. If you don't come to the field with me or with the entomologist and they show you Asian fly, you would think the drought is causing that. So this is why I'm saying it should be a law. It should be imposed that farmers in the area can only grow Asian fly resistant varieties. And the 2 new ones that Ferrari presented to the catalog are outstanding. I have a lot of hope with them. I think they will do really, really well.
Thank you, Filippo. I have another question from my colleague, our colleague from Labumad Zakaria. Thank you for the presentation. How can we adapt durum wheat to pathogen development and change in humidity with the climate change?
Yeah, I mean, I will reply this very quickly because it's a pathologist question. But to me, you partner with the pathologist. You rely on a pathologist. When I do conservation agriculture, I ask the agronomist how to do it. When I go to the doctor, I ask him, why am I sick? So when I decide to work on specific traits and interactions, including diseases, I ask the pathologist how to work on them. And they guide me whether or not to use other plant resistance, gene for gene, which germplasm, and so forth. And I have to rely on them. So this is my short answer, because otherwise it would be quite complex to reply.
There is another question, but this one, the question is why not choosing soft wheat instead of durum wheat for this study? I will answer this one. Filippo is a durum wheat breeder, so he's working on durum wheat. That's why he presented the results on durum wheat. But we will have another seminar on bred wheat inviting our Filippo Bassi. I will go to another question. Would it be useful to select a line optimized for fungi and bacteria symbiotic relations? This is also, I guess, this is pathologist question, with the idea to gain some drought resistance. So if you combine, the
there is few people around the world. Yeah, there are a few people around the world that work on this. At the moment, this is for me still too much of basic research. We don't have that. We are not at the scale where we can use it in breeding. So if there will be a breakthrough where this symbiotic relation, I mean, we even have C4 wheat, right? People are working on C4 wheat. So these are very basic research. Once they become usable, that it can be integrated into breeding, we will definitely have to do that. The symbiotic relation has potential to really improve the drought adaptation, reduce fertilizer use, increase disease resistance and so forth. But at the moment, there is nothing there. We don't know which genes are doing that. We don't know which variety of symbiotic relationship. We don't know which positive symbiotic relationship. So there's a lot of Horizon 2020 investments in this space. There are quite a few projects on that. We are involved in 2 of them. Hopefully 5 years from now, we will know better. But at the moment, it's not ready for scale.
I have another question from Dr. Ramdani. Our colleague Ramdani is asking about his comment, or actually was on seed dressing. I guess it's seed coating might be a solution mainly against Haitian fly, first generation of Haitian fly, and it can boost the durability and effectiveness of the gene major gene. It's comment on.
This is the good of having pathologists and entomologists in the group, right? they can guide us on some of this. I just want to mention that I'm noticing Gilal with his hand raised, and Dr. Amri wants to ask a question next door. Is that okay if I give him the floor 1 second?
Of course. Go ahead, Dr. Amri.
Thank you so much. I think let me first thank Filippo for having, for sharing this very valuable information related to how to cope with climate change through durum wheat improvement. I think I can see that there are a few questions that I wanted to, few considerations. One of them first is that will we continue, pushing barley and durum wheat into semi-arid areas and arid areas? In that way, I think we are not going to help much in terms of food security as food security. We this year mainly, that we have an early drought, an extended early drought, and we have seen from south of Casablanca all the way to dry areas, very yellow or dried fields of cereals, And I wanted to ask to what extent, I mean, the recovery from early drought can be a mechanism that is, I know that it is for barley. It is there for barley. How much is it really something that we can capitalize on durum wheat? And to what extent, I mean, the varieties coming from Europe, if they are bred in Europe, they should be normally having some of these traits. Let's see how they will perform this year, okay, if they are facultative. You have also mentioned one other thing that we need also to look into is that, you know, that, I mean, if I'm not mistaken, 85% of our durum wheat production is reserved from bread making, plus, I mean, some homemade couscous and bourguignon and whatever. But I mean, most of the pasta is coming from durum wheat, imported wheat. And in the past, I think I've seen that. I mean, we were making pasta from bread wheat. Okay, so what will be the balance really? What will be the strategy for you know, overcoming the high price of durum wheat at the international level in terms of making those good quality pasta? Will the consumers of Morocco will be really, you know, looking into this big difference, or they will be satisfied with
bread with
pasta? Okay. I think I will stop here, because I think I see that, I mean, your durum wheat in the desert area deserves a lot of thinking, because I think it's still a matter of what availability of water.
Yes.
And it has to be, you know, really calculated, evaluated on the basis of economics of water. Thank you so much.
Okay, is that okay if I reply some of those?
Yes, of course. Go ahead, and we'll
very quick.
Close just after answering the question of Dr. Henry. We'll close the session. Go ahead. Go ahead.
So very quickly, I think durum wheat productivity, there's a reason why it's in dry area, and it's because it adapts better, and especially gets higher protein and it gets higher price. So what you lose in terms of yield, you gain in terms of price. Now, for a country like Morocco, where you still have more than what you produce is imported, I feel that that's a decision that needs to be taken high level. It is surprising to me that Morocco selects bread wheat as major production area, when the price per ton is lower, and there's many more countries around the world that can export bread wheat. There's a lot of export of bread wheat, but of durum wheat and barley, there's very little exported. So that's why I'm thinking, from my point of view, that maybe there should be a plan to look at the cost per ton. Like right now, durum wheat is a $700 per ton. Bread wheat is a $320. It's double. It's not a little bit more, it's double. So it's much better for a country to import bread wheat and produce durum. So that's something that I think a reflection is probably correct. Now, you asked me if you want to make pasta with bread wheat. I should ask you, would you like to make couscous with bread wheat? Because, you know, that's the same. To me, it's the same. It's the same question. Now, there's barley. Why don't we make pasta with barley? That's more interesting to me. That's a much more interesting question. With that, about the recovery, I think is a very interesting line of research. I doubt that the European variety will make it, because typically when drought occurs, those were the first one to go. Karim was actually much more stable and tolerant than the other, but we will see. We have them in the field, we will know. Yeah, I stop there, sorry.
Thank you, Philip. I will say also, this week I was going around the multiplication trials, and I have seen some recovery from some varieties. But the problem, can this variety make it? We have only 1.5 months left for the cycle. They will not make it. There is the cycle we have, it's already finished as of now. Okay, I will close the session. Sorry for the other colleagues that want to talk, because they asked me to close the session. And thank you, Dr. Filippo, for your talk. That was rich, and we really appreciate sharing with us all those results. And thank you so much. I give the floor to you, Badr.
Thank you, Dr. Farahi, and to you also, Dr. Filippo. It was very rich. And sorry for people who have asked other questions, but we cannot extend the session more and more. So we are reaching now the end of this webinar. I would like to mention to everyone that you will get, by leaving the webinar, you will get a very short survey to get your assessment of this webinar series. Please fill it, it will be helpful. At the end of this questionnaire, there is the possibility to request your attendance certificate for those who want it. Finally, on behalf of the organizers, I would like to thank everyone who participated today and thank our guest speaker, Dr. Filippo Bassi, for this talk, and Dr. Moha Farahi for his rich contribution in this webinar. I would like to thank also Dr. Fawzi Bikawi, Director of INRA, Dr. Abdelaziz Yasri, Dr. Tami Alami, and Dr. Tariq bin Abdul Wahab for the great discussions and suggestions to prepare this webinar. I would like also to thank warmly my colleagues Butaina Abidou, Uthman Sabbatar, Dat Tirazi, and Abdelaziz Yasri, and all the scientific committee of the INRA webinar series for their crucial contribution in the organizing of this series. Dr. Bassi, do you want to say something before leaving?
It was my biggest pleasure, and I want to say hi to a couple of people that I've seen in the chat, Matugi, Fernanda, they are old friends. Thanks for joining, and thanks everybody for joining.
Dr. Farahi, do you want to say something?
Oh, thank you, Badr. That's all.
So the next webinar, it will happen in a month, in the 14th of April. So see you next month. Bye to everybody. Bye. Thanks.